My name is Nandan Talluri, and today I'll be presenting on isolation forest, unmasking anomalies in your data. In today's data-driven world, organizations generate massive amounts of data every second. Hidden within this data, hidden within this data are usually unusual patterns, some of which can identify serious problems in fraud, cybersecurity attacks, or system failures. Detecting these unusual patterns efficiently is very important, and that is exactly what anomaly detection helps us achieve today. I'll explain how Isolation Forest provides a smart and efficient way to detect such anomalies. Now, let us move to slide 2. The hidden threat. What are anomalies? Let us begin by understanding what anomalies actually are. Anomalies are called outliers, are data points that behave very differently compared to rest of the dataset. They do not follow the normal patterns or trend. Now, these anomalies are not always errors. In fact, they're often called the most important data points of the data. For example, in banking systems, let's take banking as an example. An unusual large transaction from an inactive account could also indicate fraud. Only because from an unusual bank account, doing large scale of transactions is also can be indicated as fraud. In cybersecurity, abnormal network traffic might signal on ongoing attack. Similarly, in industrial systems, unusual sensor reading may indicate that a machine is about to fail. So, anomalies act as warning signals. Detecting them early allows organizations to take actions before problem becomes serious. So now let's move to slide 3. Why traditional methods systems work. Conventional anomaly detection techniques face significant challenges. Now let's understand why traditional anomaly detection methods are not always effective. Most traditional methods focus on understanding what normal data look like. But in real world data sets, defining normal behavior is extremely difficult because data is often complex and constantly changing. So, another major challenge is that anomalies are very rare. Since they occur infrequently, there is very little amount of data available to train models. Also, modern datasets can have hundreds or even more than thousands of features. In such high dimensional data, distance based or density based methods become inefficient and inaccurate. Finally, manual inspection is simply not possible at large scale. So, because of all these challenges, we need a method that is simple, scalable, and does not rely on defining normal behavior that where isolation forest comes in. Now, let's move to slide 4. Slide 4. Enter isolation forest, a new paradigm. Isolation forest introduces a completely new way of thinking about anomaly detection. It was proposed in 2008 by Fei Tony Liu and his colleagues. Instead of trying to model normal data, this algorithm focuses on isolating anomalies directly. The key idea is based on a simple observation. Anomalies are both rare and different from normal data points. Because of this, they can be separated more quickly when we randomly split the data. This approach is very different from traditional techniques, and surprisingly, it works extremely well in practice. Now let's move to slide 5. How isolation forest works. Now let's go deeper into how the algorithm actually works. Isolation forest builds multiple trees called isolation trees. In each tree, the algorithm randomly selects a feature from the data set. Then it randomly selects a split value within the range of that feature. The split divides the data into two parts. The process is then repeated recurrently on each partition until every data point is isolated. Now here's the key insight. Anomalies, because they are different, tend to isolate it very quickly, often in just a few splits. On the other hand, normal points require many splits because they are part of these regions. This difference in isolation speed is what allows the algorithm to detect anomalies. Now let's move to slide 6. The power of isolation forest. Isolation forest has several advantages that makes very powerful. First, it is combinatorially efficient. It has a time complexity closer to linear, meaning it can handle large data sets quickly. Second, it scales very well to high dimensional data. Even if the data has many features, the performance remains stable. Third, it is an unsupervised algorithm, which means it is not required labeled data. This is extremely unusual in real world situations where labeling anomalies is expensive or impossible. Because of these properties, isolation forest is widely used in industries. Now let's move to slide 7. Real world impact uses cases in data warehouse and mining. Let's now look at where isolation forest is used in real life. In banking, it is used to detect fraudulent transactions by identifying unusual patterns in spreading behaviors. In manufacturing, it monitors sensor data to detect early signs of machine failures. In cybersecurity, it helps identify unusual user behavior or network activity that could indicate a security breach. It is also used in complex systems where multiple variables interact, such as financial markets or IoT systems. This is how versatile and impactful the algorithm is. Now we'll move to slide 8. Advancements and app improvements. Over time, researchers have improved isolation forest in several ways. One important advancement is online isolation forest, which can handle streaming data in real time. This is especially useful in applications like fraud detection and must be made instantly. The cybersecurity where decisions must be made instantly. Another advancement is its integration with modern data platforms like data lakehouse. These improvements make isolation forest even more scalable and practical for modern systems. And then one important advancement in online isolation forest, which can handle streaming data in real time. This is especially useful in applications like fraud detection and cybersecurity, where decisions must be made instantly. Another advancement is its integration with modern data platforms like lakehouses. These improvements make isolation forest even more scalable and practical for modern systems. Now, let us move to slide 9. In slide 9, let us consider a practical example. Suppose we are monitoring an industrial machine using IoT sensors. These sensors collect thousands of readings across multiple variables. These sensors collect thousands of readings across a multiple variables. Using isolation forest, we can analyze this data and detect unusual patterns. For example, if the temperature of vibration suddenly behaves differently, The algorithm with flag is an anomaly. So, this allows us to detect potential failures early and take prevention actions. In real implementations, the algorithm can achieve very high detection accuracy. So, these sensors collect thousands of readings across multiple variables. Using isolation forest, we can analyze this data so that and detect unusual patterns. For example, if the temperatures of vibration suddenly behaves differently, the algorithm with the flag is an empty anomaly. So this allows us to detect potential failures and take preventive actions. In implementations, the algorithm can achieve very high detection accuracy. Now let us move to the conclusion. Now coming to conclusion, the 10th slide, conclusion, your shield against the unexpected predictions. To conclude, the isolation forest is a powerful and efficient solution for anomaly detection. Its key strength lies in its unique approach of isolation. Anomalies instead of modeling normal data. It is fast, scalable, and works well even without labeled data. As data continues to grow in size and complexity, such algorithms becomes essential tools for data analysis. Isolation forest helps organizations detect problems early and improve decision making and gain valuable insights. So now we can conclude that isolation forest is a powerful and efficient solution for anomaly detection. Its key strength lies in its unique approach of isolation and anomalies instead of modeling normal data. Instead of normal data, anomalies can be approached in isolation. Then it is fast, scalable, and works well even without labeled data. As data continues to grow in size and complexity, such algorithms becomes essential tools for data analysis. Isolation forest helps organizations detect problems early and improves decision makings and gain valuable insights. Thank you.